So starting chapter 9, section 4, we are now going to be looking at something called a series, which I do not want you to confuse with a sequence. Today we're just going to focus on the arithmetic series. We'll talk about the geometric one next time. So the difference between a sequence and a series is that a sequence is just the listing of those terms. So we've already learned, for example, this explicit rule creates a sequence. If you plug in k equals 1, you get 3. If you plug in k equals 2, you get 5. If you plug in k equals 3, you get 7, etc. So you can create a sequence of numbers by plugging in bigger and bigger numbers for k. So a pattern has been created, and that's the sequence. The series, which is what we're focusing on today, is those numbers being added together. So some problems will say something like find the sum of the first 5 terms in the sequence. So if you were just adding the first 5, you could write them out and add them up, but we're also going to go over some formulas for when you're doing something like adding 50 terms in the sequence together, because that would be too much. It would take too much time to sit there and add them all up one at a time when you have a bunch of numbers. So as I said before, today we're just focusing on an arithmetic series, and the important term right here is that this is a finite arithmetic sequence. So if we are adding the terms in a finite arithmetic sequence, I'm saying that there's a set number of terms we're adding, like we're adding 10 numbers together or 20 numbers together. Later on, we'll look at some possible ways of adding an infinite number of numbers, because there are some restrictions that have to be met for us to be allowed to do that. So for now, if we're adding a certain specified number of terms, like 10 terms, the formula is the first term in the sequence plus, this is the way to say the last term of the sequence. The problem is I don't know if the last term will be the 20th or the 30th. So I can't write a sub 20 or a sub 30 because this is the general rule for however many terms they want us to add together. So for the time being, it has to stay as an n, but basically this is the last term in the sequence, which is an important thing to add into your notes. So if you take the first and the last number and divide them by 2, add them up, divide by 2, and then multiply by however many numbers you have, like if they said add the first 10 terms together, then this n value would be 10, because you're adding 10 numbers together. That would be the sum of all of those numbers together. The way I remember this rule is by noticing that we're basically averaging the first and the last term in the sequence. So if we're doing the first 10 terms, put the first term and the 10th term in these two spots, add them up, cut it in half, and then multiply by the number 10, which is how many numbers we are adding together. So that's what this formula is telling us to do. I went ahead and wrote in what each of these variables is referring to as well, just to make sure you guys understand what numbers you're plugging in where. So the last term, the first term in the sequence, and then n is the number of terms in the sequence. So here's our first example where we're going to find the sum of the sequence that is 73, then 68, and 63, and 58, etc. Well, one of the first things you want to do is start labeling as much information as you can. Right here, I have my a sub 1 value. I know that the first term in the sequence is 73. Here, I know that the last term in my sequence is 18. The problem is I don't know what n is, so I don't know if that ended up being the 10th term or the 15th term. I can't tell from looking at this because they didn't want to write out all of the terms in the sequence. This is a common thing to do when you have a whole bunch of numbers listed out. So they're just showing that we have a pattern going on, so we could continue to fill in the pattern, but to save space and time, they just said, and the last term is 18 following that same sequence. So I know the first term and I know what the last term is, but I don't know how many terms I have. There's one other piece of information I can find, and that's the d value. Because remember, I can pick any number in the sequence as long as I know the one in front of it, because I can subtract to find what that other number is. For example, if I pick 63 and then subtract the number in front of it, 68, then I just found that d is -5. So this number is telling me that my pattern is subtracting 5 at a time. And I would have gotten that same answer if I had started with 58 and subtracted 63, or if I had started with 68 and subtracted 73. No matter which numbers you pick, you should be able to find the difference by picking a number and subtracting the one in front. So with these 3 pieces of information, let me remind you guys of the formula for the explicit rule of an arithmetic sequence. We know that a sub n is equal to a sub 1 plus d times n minus 1. Well, I could use this formula to solve for n because I know the other 3 terms. I know a sub 1, I know a sub n, and I know d. So there would only be one variable left. So let's plug in the information we have, like 18, 73, -5, and then I'm going to leave n as is. That's the number I don't know. So I still have an n minus 1. If I subtract, well, I'm just going to solve this equation, so perform opposite operations. So first I'm going to do 18 minus 73. So we have negative 55, and this equals negative 5 n minus 1. So next I would divide by negative 5, which would give me 11 equals n minus 1. And then my last step would be to add 1 to both sides. So 12 is equal to n. Now, this one wasn't a super large number of numbers. I could have figured out what n is by continuing the pattern and saying the next number is 53, the next number is 48, and then 43, and then 38, and 33. I could have counted all the numbers up at the end, but sometimes it is going to be replacing like 50 terms in the sequence when they just write a dot, dot, dot. So this is the formula way of doing it, in case it's a whole bunch of numbers and you don't want to sit there and write them all out and count them up. So now that I know n, I know a sub 1, I know a sub n, we have everything we need to find the sum. So s sub n is equal to the number of numbers I have, which we just determined as 12, and then it's the first term in the sequence plus the last term in the sequence, and this always gets divided by 2 because I'm averaging and I'm adding two numbers together. So how many numbers did I add? Divide by that same number. Well, the 12 and the 2, since I have a 12 over 1 times 2 in the denominator, you can actually do a little bit of cross-canceling there and just make this into a 6 right away. And then I also have to compute 73 plus 18. So this is going to be 6 times 91. And then if I multiply those two numbers together, I got 546. This is the answer I would get by sitting there and writing 73 plus 68 plus 63 plus 58 plus 53 plus 48 and hitting it over and over and over again in the calculator. But again, I'm showing you with a sequence that only has 12 terms so that when you get a sequence that has like 100 terms, you know how to use the formula. Please don't sit there and just add the numbers up one at a time. Here's a second example, and again I want to start off by identifying what information I can. So in this case, I do know what a sub 1 is, because they've given me the first couple terms in the sequence, and I do need the first term, that's important. They've also told me what n is, and the last thing that I can fill in is I should be able to figure out d, since they gave me a couple terms right next to each other. So if I pick a term in the sequence, like 13, and I subtract the number in front of it, now I know that this sequence is adding 4. The fact that it's a positive number means it's adding. So add 4, and again, I can fill in the other numbers by adding 4, adding 4, adding 4, adding 4. But I'm trying to show you easy examples that only have 8 terms, so that when you get to the uglier ones later on, you know how to use the formula. So again, I want you to use the formula for now, not just write out the terms and add them up. So the formula for the explicit rule of an arithmetic sequence is a sub n is equal to a sub 1 plus d times n minus 1. Well, if I plug in the terms I know a sub n in this case, so that's going to stay as a sub n. But I do know the first term in the sequence. We said that was 5. And we know that d is 4. And this time we know what n is. Last time we didn't. So now they told me that there are 8 numbers in the sequence. So I'm just going to go ahead and do 8 minus 1 is 7. So I only have one variable left. That means I can find my answer for a sub n by just computing what's on the other side here. I don't even have to do opposite operations. Well, order of operations, 7 times 4 is 28. And then if I add 5, I get 33. And again, this would have been pretty easy to just sit there and add 4, add 4, add 4, add 4 until I had 8 numbers total. But I want us using the formulas for the bigger, longer sequences. So now I have everything I need to figure out the sum, because the 3 variables I need from the equation are n, which is 8, and then I need the first term, which is 5, and the last term, which is 33. Those two numbers get added together, and since we're averaging them, I'm going to divide by 2, always dividing by 2. So here I have what needs to be computed. I could do the 5 plus 33 and then cut it in half, or just like I did in the last one, I can recognize that this reduces. So this is going to be 4 So now I have 4 times, and 5 plus 33 is 38. So then the last piece is just to do 38 times 4. So this is the answer you would get if you wrote out all of the terms in the sequence, all 8 of them, and then sit there and hit 5 plus 9 plus 13 plus 17, etc. So this is the sum of the first 8 terms of the sequence. And that's it for the notes.